The next part of activity 2.1 covers negative exponents. I wonder, what is the significance of the negative 3 in this expression, right? Y to the negative 3. If you think about it, well, how did the negative 3 arise? If I had y squared over y to the fifth, you remember the division property tells us we subtract the exponents. So we would have y to the 2 minus 5, which leaves us with y to the negative 3. Now, I really don't like to leave my final answers with negative exponents, so how do I handle this negative 3? Well, let's take a look down here. If we wrote out the common factors and canceled, y squared becomes simply y times y on the numerator. Y to the fifth would be y times y times y times y times y, 5 times. When we cancel out common factors, we're left with 3 y's on the bottom, and we would just have a 1 on the top. So y to the negative 3 can be written as 1 over y cubed. So both of these answers are correct, but I prefer my final answer to be written with positive exponents. So instead of you leaving your final answer as y to the negative 3, you'd have 1 over y cubed. And then if you take a look, they're saying, okay, well, if we had x to the negative 2, we could write that as 1 over x squared. 3 raised to the negative 4 can be written as 1 over 3 to the positive 4. So really what we're doing, if we have a base that's raised to a negative exponent, we take the reciprocal of the base and then make the exponent positive. So the reciprocal of x is 1 over x, and then my positive exponent would be positive 2. The reciprocal of 3 would be 1 over 3, and again I make my exponent positive. So the negative 4 becomes a positive 4. And then here they give us, I guess, the symbolic representation of that, right? A to the negative n is the same as 1 over a to the positive n, right? The reciprocal of a is 1 over a, and then we make our exponent positive. So let's try a few practice problems. So when I look at number 52, everything in the parentheses is raised to this negative 3. So the reciprocal of what's in the parentheses would be 1 over negative 4, and I would make my exponent positive. So first I took the reciprocal of negative 4, which is 1 over negative 4. I made my exponent positive. Now 1 cubed is just 1. And then we're left with negative 4 cubed, which becomes negative 64. Let's take a look at number 54. Well, my base is 3 over 2, so I can take the reciprocal of 3 over 2, which is 2 over 3, and make the exponent positive. And then we can do the repeated multiplication, right? We're going to have 2 squared over 3 squared, or 4 over 9. And here's the rest of this problem worked out. Let's take a look at problems 56 through 68. It says rewrite the expression with only positive exponents. So with 56, my base is b, so I'll write 1 over b and make the exponent positive. 58, I have 1 over x to the minus 4, so I'm going to actually take the reciprocal of 1 over x, which would be x over 1, and make my exponent positive. Another way to think of it, this is, if my exponent that's negative is on the denominator, move it to the top. If my exponent that's negative is on the numerator, just move it to the bottom and make the exponent positive. So when we look at number 58, my exponent that's negative is on the denominator, so I'll move it to the numerator and just make the exponent positive. All right, so I now have the x to the 4th over 1, or just x to the 4. For number 60, the b stays where it is, but this x to the negative 2, well, the x is going to come down, and we're going to make the negative 2 positive. So you see we're left with 1 over x squared times b. Number 62, the 4 stays where it is. The x has a negative exponent attached to it, so I'm going to bring the x to the numerator and make the exponent positive. And you can see we're left with 4x. Let's take a look at number 64. With 64, the x to the negative 4 is going to come down, and we're going to make the x, the negative 4 positive. The a to the negative 3 is going to come up, and we're going to make the negative 3 positive. And the 2, that just stays where it is. The 2 does not have an exponent directly attached to it. So you can see I'm left with a cubed divided by 2 times x to the 4th. Number 66, my base is 3 over x, so I'm going to take the reciprocal to get x over 3 and make my exponent positive. So you can see I'm left with x over 3 quantity squared, which becomes x squared divided by 9. Because remember, this 3 is raised to the 2 to give me 9. Okay. And number 68, I think that's the last one. So last but not least, and this looks tough, so maybe you want to pause the video and try 68 on your own before I put the answers up. I'll wait. So when I look at 68, note the negative 2 does not have an exponent, so the negative 2 is not going to move. The x does not have a negative exponent attached to it, so the x is not going to move. The y, that's going to move because we have a negative 1. So I'm going to bring the y into the denominator and make the negative 1 positive. I'm going to bring the z to the numerator and make the negative 2 positive. The w squared stays where it is. So you can see we're left with negative 2x times z squared. That's coming from down here, right? We bring the z up top and make the exponent positive. W squared and the y to the negative 1 becomes y to the 1. And this is your final answer. Some people choose to just leave this as w squared y and they don't show the 1. Right? The 1 is optional. So another way to write your final answer could be this way.